All right. With me today to talk about population growth is a very smart man. Maybe you had him for physical science. It's Mr. Sorali, also a chemistry expert. So anyway, to start this off, I'm going to ask Mr. Sorali, what are some possible things that could actually affect the size of a population? We're not just talking about humans. We're talking about
Well, it
animals in the
seems to
wild.
me like food.
Yeah.
It seems to me like the environment,
Okay.
um, the the amount of sickness.
Okay. So things that can not only support the environment, but also things that can kill people in the population. Okay.
Yeah, those are definitely factors.
Yeah, and you're kind of, especially when you're talking about disease, you're getting into like mortality there. But here are four factors that, and this is a little bit vocabulary heavy here, but four factors that actually change population size. So these are all types of rates. So natality refers to the birth rate of a population. How many people are being born into the population? I think it's something like 4.5 people are born into the world every second, and it's like 1.6 people die every second.
So there's a
the world.
balance between the number of people who are being born versus the number who die.
Right. Especially if we're in logistical growth, which we'll talk about in a minute. But
Okay.
Mortality is the death rate, so the rate of how many people on average are dying in a population. But that's not the only way people join a population. People either immigrate in, and I shouldn't keep saying people because we can even talk about, squirrels living out by the Des Plaines River. A squirrel from another area can move into that area, and that's immigration. And emigration is, let's say that squirrel decides to leave and goes across a plain, like how I'm pointing as if they can see where I'm pointing, but they can leave to go to another environment. That's emigration.
So you've got two things going on here.
Mm-hmm.
Individuals dying, individuals being born,
Yep.
and individuals coming and going.
Right. So there's the birth and death kind of category, and then the just people simply moving in and out.
Okay.
And if you look at if you actually look at how population size changes over time, if it stays the same, that means that natality and immigration are equal to the mortality plus emigration. Because mortality and immigration are things leaving the population, natality and immigration are things coming in. If natality and immigration are greater than mortality and emigration, then the population size is going to increase.
And then you can start having problems.
Right. Especially if it's a wide open new environment, it's not necessarily, but yeah, if you have an area that's already heavily populated, then yeah, you could have some
Food could
problems.
become a problem.
Right,
Yeah.
exactly. And that's typically why sometimes people emigrate then and leave to go somewhere else. And so, yeah, if natality and immigration are lower than the mortality and the emigration, then the population size decreases.
That's like going to the resort in Cancun,
How's that?
because then there's plenty of stuff there to eat. There's plenty of stuff there to live on.
Yeah. So we're going to talk about the two growth models. And as we'll learn, this one on the left actually kind of turns into the one on the right. But anyway, the first one is called exponential growth. Now, exponential, what does exponential mean?
Continuous without end.
Right. So, and like when we do that in math too, we have the little number up in the thing. That means that it's growing more than just things being added. It's actually going a bigger increase, then a bigger increase, then a bigger increase. And this is exponential growth in a population occurs when, things are just reproducing and there's not too much reducing the population. So all those kids reproduce. It's kind of like when I was a kid and I was bored in not in chemistry class, of course, but in math, I would sit there with my calculator and hit 1 times 2 times 2 times 2, and it'd go to 4, 8, 16, 32, and it'd go really, really fast to keep increasing. That's exponential growth.
In a population.
Yeah, in a population.
When there's nothing stopping it.
Right. Now, this can't go on forever. There's not a single area in this world that can just keep exponentially growing. What
about heaven?
Now we're getting into, I don't know. That's a good question.
This would happen in paradise, wouldn't it?
I suppose, yeah.
Okay.
In ideal conditions,
There's
yes.
no paradise on earth.
Yeah.
All right.
Yeah.
So what would happen if there's no paradise?
Then
Then the next thing.
the next thing, yeah, logistic growth. Sorry, I thought you were asking a deeper philosophical question for a
I
second.
was just trying to lead you into
Thank
this
you, I
business
appreciate
about
that.
carrying capacity.
So yeah, logistic growth is so what we discussed, exponential growth is kind of this first half of the chart. But, at some point food gets a little bit scarce, there's not as many places to live, and then you'll notice population kind of naturally starts to slow down as far as how it's growing. and it'll start to taper off. We like to call this an S curve. I know it doesn't really look like an S, but it, you know, if you kind of look at it sideways and everything, maybe a little bit. But the reason why it especially levels off at the end is it reaches something called carrying capacity. And that's the maximum number of individuals that a particular environment can actually support of some species. The projections for Earth are apparently set, I think, 14 billion for people. We're at 8. So we're more than halfway.
So when we hit 14 billion, things are going to start to suck.
Yeah, for sure. Yeah, and we're going to get more into the darker stuff with my next video on what happens when you get past carrying capacity.
Things I would assume start coming down.
Yeah, like
as far as the...
Well, the whole idea is once you get past carrying capacity, then by rule, individuals have to die, whether that be because the population is actually selecting people to die or there's just simply not enough food and people
But at carrying capacity, if you stay there, then all the individuals in the environment can live and can live and can live and never die and not die.
Right, but that usually needs completely equal distribution of resources. So you'll typically see things taper off just below carrying capacity.
Oh,
because I don't think there's a single organism on the earth that actually will recognize carrying capacity and then be like, all right, you get exactly 500 calories of food.
Yep.
So
nothing's perfect.
Yeah. So anyway, now biotic potential, we were talking about exponential growth. Biotic potential is what the population size would normally get up to under absolutely ideal conditions, where there's no limit to food, no limit to space, anything like that. And what kind of growth displays something reaching its biotic potential? It's exponential growth. But as we said, it doesn't really happen. So any population size you see, whether you're a scientist, you're going and looking at how many squirrels live in this area or how many aphids live in a soy field or something. Population size, whenever you measure it, you know that's really a measurement of a balance between that biotic potential, what the population size would be, and the carrying capacity, which is how the environment is actually regulating that. Yeah. So that's all. That's kind of an introduction of how populations grow. So that was actually it for today. A reminder to my students to do their checkpoint.
Well,
anything to add? Any more questions? Or?
Nope. Except thanks for asking me to. I learned a lot. Thank you.
Thanks for coming on.
You're welcome.
Like this is a radio show. See you later.